A pilot takes a taxi from the airport to a hotel. The taxi driver charges a $2.50 initial charge plus $2.65 per mile, which equation can be used to find y, the total cost of the trip, if x represents the number of miles of the trip. So we need to identify which one's the coefficient and which one is the initial amount. So who could tell me what the coefficient is? Yeah, it is $2.65 because it's telling you that it's per mile. Per mile. Whenever you have that, that means that that's gonna be your coefficient. Now, if you think about it, it says there's a charge of $2.50 initial charge. Well, this word initial is your initial amount. It's the amount that they started off with. So then the way you would write it is, because this is your coefficient has what? Is it are you adding it only, or what are you doing with it? Yeah, you're multiplying it with the number of miles. But we don't know the number of miles, so then that's going to be y equals $2.65 times the miles, which is x, plus $2.50. And that will give us letter, oh yeah, J. Couldn't see that one. Okay, number 2. The distance between two cities on a map is 3.5 centimeters. The map uses a scale in which 1 centimeter represents 20 kilometers. What is the actual distance between these two cities in kilometers? So basically, when they give you centimeters, but then they gave you a scale. Scale, that's an indication that you're using that one chart. So what you do is you do centimeters over kilometers. Okay, they're telling you that 1 centimeter equals 20 kilometers. So then they want to know how much 3.5 centimeters equal to. So that's what we're looking for. That's our letter X. So what do we do in this case?
3.5 times 20.
Yeah, so 3.5 times 20. So I know that's 0, and then 2 times 5, 10, 2 times 3, 6, plus 1 is 7. So then I have one decimal place. So does it make sense that 3.5 kilometers equals to 3.5 centimeters, sorry, equals to 70 kilometers? Yes, so it's going to be 70 kilometers between the cities. So any questions on that? Okay, well, make sure you turn in your warm-ups. So here we have two spinners, and we are going to do compound events. And remember, compound events, you found the probability of one event and then the probability of another event, and then you multiply it to give you the probability of both events. So both events happening. It's like when you actually randomly pick something or roll something or anything, this is the probability of getting one thing first and then another thing second. And sometimes that's hard to predict. That's why your numbers grow so big, because the probability of getting that same order every time is less of a chance than getting just one activity, one event. Does that make sense? No? Okay. So it says the two spinners below are spun at the same time. This is an independent or dependent event. So is it independent or dependent? Independent. And the reason it's independent is because really the totals can't change. The spinners stay the same. You can't take off one section and spin it again, right? So that's why those are independent events. So then what we're going to do, it's going to say, what is the probability of the first spinner landing on 4 and then the second spinner landing on A? So we're going to go ahead and do the probability of 4, then A. Okay, so that's gonna equal, so the probability of getting a 4 on the first spinner is 1 out of 8. And guys, the quiz that you did before the spring break, I am giving them back to you. I'm giving you back the test also and giving you a schedule of when we're doing the retest. But that, some of the mistakes I saw is that you guys didn't count the sections correctly. You guys were giving me, there were 12 sections and you told me there were 13. So make sure you're counting them. You're counting the sections. Okay, the second spinner is landing on A would be 3 out of 6. Now I'm going to simplify that to what? 1/2. And then I'm going to multiply it. So 1 times 1 is 1. 8 times 2 is 16. So the probability of getting 4 and then A will be 1 out of 16.
Wait, you do 1/2 times 1/8.
Yes, I did 1/2 times 1/8. Because once I simplify it, I actually just cross that out. I don't use that one anymore. Okay, on the next one it says, what is the probability of the first spinner lands on 1 or 2, and the second spinner on B? So again, we're going to do the probability of 1 or 2, then B. Well, remember, when they're asking you one or another, okay, basically you're adding those two probabilities, right? So then what we need to do is see how many are 1s. That's 1, right? And how many are 2? That's another one. So that means the probability of getting 1 or 2 is 2 out of 8. Okay, and I'm going to simplify that to what?
Wait, can you?
1/4.
Miss,
Yes.
can you explain that again?
Okay, so the probability of getting 1 or 2, because this is for the first spinner, you're looking at how many are 1s, how many are 2s. In this case, there's 1 1 and 1 2. So you count them together. So now the probability of getting 1 or 2 is 2 out of the whole thing. So you're adding the probability. So I know that to get 1, probability of 1 is 1 out of 8. And then the probability of 2 is 1 out of 8. I'm going to add those up, which gives us 2 out of 8. Does that make sense now? Okay. So now we have 1/4 times, now we want to do the probability of B, which is 2 out of 6. And I'm going to simplify that to 1 over 3. So now I just multiply it. 1 times 1 is 1. 4 times 3 is 12. And that means the probability of getting 1 or 2, then B is going to be 1 out of 12. So now if you look at it, the chances of getting that is a little bit better than the first one, right? And the reason is because now the first spinner has 2 numbers it could land on. Okay, so the more you add into the spinner, the better it's going to, your probability is even a better chance. Okay, let's look at the last one. It says, what is the probability of the first spinner lands on an even number and the second spinner not landing on C? Okay, so let's go ahead and do that. So P equals even number, then not C. Okay, so even numbers, if we look at it, there's going to be 1, 2, 3, and 4. So the even numbers is 4 out of 8, which we simplify it to 1/2 times, not getting a C is 5 out of 6. And in this case, it stays the same, right? So then I'm going to go ahead and multiply those two fractions or ratios. So 1 times 5 is 5. 2 times 6 is 12. Can I simplify that? No. So see how now this one's a better chance? There's a greater chance to get even number and not C? Because again, the probability is growing, so that means the chances are better, yes.
How did you get the 1/2?
The 1/2, because I divided 4 out of 8 by 4.
Oh,
Okay, any other questions? No? Good, okay. So let's go to the bottom part. Okay, bag contains tiles with the letter R, U, D, D, E, R. Okay, it says find the probability if you were to pick a letter, replace it, and then a second is picked. What is the probability that you will pick the letter D and then the letter D?
what if the independent?
That's independent. And what tells you that it's independent?
The word
Replace
replace.
tells you it's independent. So let's go ahead and do the probability of D, then D. So the probability of getting D would be what? 2 out of 6. And that simplifies to 1 out of 3. Times, what's the probability of getting a D again? 2 out of 6, which is the same as 1/3. So then I multiply it. 1 times 1, 3 times 3. So our answer is 1/9. Okay, and the second one. Find the probability if you were to pick a letter, not put it back, and then a second letter is picked. What is the probability that you will pick the letter U and then R? So is this an independent event or a dependent event? Dependent. What tells you that it's dependent? Not put it back. Not put it back. Okay, so that means my totals are going to change, right? Yes? Okay. So probability of getting a U, then an R. Okay. So what's the probability of getting a U? 1 out of 6 times what's the probability of getting an R?
2 out of 6. Oh, 2 out of 5.
2 out of 5. 2 out of 5. Don't make that mistakes because we said it was a dependent event. So that means our totals are going to change. Because if you pick a U, you keep the U. So that means that in the bag, there is only 5 letters. So now we multiply it. So this becomes 2 over 30. I could simplify it by dividing by 2. So this becomes 1 out of 15. Okay, and the last one says find the probability if you were to pick a letter not replaced and then a second is picked. What is the probability that you will pick an R both times? So was this independent or dependent? Dependent. What tells you that it's dependent? Not replaced. Not replaced. Okay, so let's go ahead and do probability of R, then R. Okay, so in this case, what's the probability of getting an R? 2 out of 6, and that becomes 1/3 times, what would be the probability of getting a second R?
2 out of 5. 2 out of 3.
1 out of 5. Guys, when the probability of the R and you pick the R, you're keeping one of the R's, right? So then you're not putting it back, so that means the number of R's in the bag are less. Yes?
Wait, you take the R out, so would it be 0 out of 5?
No, because there's 2 R's.
Okay, and
So if you get 1 R, then there's still another R left over, right? Okay, so you're not taking both R's out, you're just taking 1 R out. Okay, so now we multiply it.
Miss Mendoza,
Yes.
kind of confused.
Okay, so think about it. So right now, I am going to go in the bag and I'm picking, when I take it out, it's the R. So that means I'm keeping that R. Okay? Now the second time, I want to pick an R too. So what's the probability that I'm going to get an R again? So if you look, there's 5 letters now, and there's 1 R. And that's how I got 1 out of 5.
Okay.
Got it? Okay. So now, all we do is multiply. So 1 times 1,
Is 1.
and 3 times 5.
15.
So then my answer is 1/15.
So then, in the beginning, how did you get 2 out of 6?
Because there's 2 R's at the very beginning. You haven't picked anything out. There's still 2 R's. There's 1, 2 out of 6 letters. So that's how I got 2 out of 6.
Oh.
Okay, and then I just simplified it. So that's the problem, that when we are working on this, we need to make sure that we know that it's dependent. And when it's dependent, that means your probability is going to change, which means the totals are going to change. The numbers are going to change. So be careful you're doing that. That goes in your composition book. So this goes in your composition book. Like I said, you are going to finish up yesterday's assignment. If you didn't get one yesterday, make sure you get one today. And you're finishing up any assignment from this week that you have not completed. This other one that I'm giving you, or you want, if you want to get it, it is extra credit. Like I said, I won't count it against you, but you will be able to get points towards it. Any questions before you start? Okay, then get to work, and this will be in Google Classroom.